So positive or 0. But the value of the game, if positive negative is there, chance is maybe the 0. But here positive and 0, the value of the game is expected value of the game is positive. So with respect to this, we have to. So we conclude here this game is unstable because row minimum 0, then maximum is after taking the minimum, take the maximum, that is coming 0. Then after taking the column maximum, then take the minimum, that is becoming 2. They are not same, 0 and 2, they are different. So game is unstable. With respect to this unstable game, we have the formulation. We like to maximize that new, and that new is less than or equal to 2x1, also less than or equal to 3x3, and also less than or equal to 4x2, and sum of this is equal to 1. So once you are simplifying, we have the solution. So here the new is not restricted since it is, when the elements are 0 or positive, the new has to be positive. Okay. So, and if you are simplifying, we are finding x1, x2, x3. This x1, x2, x3, these are the probability of using strategy A1, A2, A3. And we have y1, y2, y3. These are the probability of using strategy B1, B2, B3. And their sum equal to 1. And so we are finding the value of the new. What is new? New equal to, say, here you can see new greater than or equal to, so 2, the new by 2 equal to y1, new by 4 equal to y3, and new by 3 equal to y2. So, and if you are adding y1, y2, y3, their sum equal to 1. So as a result, we are finding, so this new equal to, say, 12 by 13. New equal to 12 by 13. So this is the expected value of the game. Since it is positive, it is a gain for the player A. So I have already told. So since the elements are 0 and positive, the value of the game equal to positive. Okay. Similarly, the same problem we can also solve using there are two problems. For player A, one problem. For player B, another problem. So if you solve, you will find the optimal strategy. So it is given here x1, x2, x3, y1, y2, y3, and their sum equal to 1. Okay. If you have any doubt, you can ask me. I will clarify. Hello? You are available? How many students are available?
Present, sir. Yes, sir.
See, I have told.
Yes, sir.
See, the information is like this. Say the dual simplex method is also included. Okay, dual simplex method. Why? Because since the integer programming is there, in the integer programming we use dual simplex method. So the dual simplex method is included. Okay, dual simplex method. See, I like to mention. So one problem, a linear programming problem, if you are naming it is primal. So with respect to the primal, we have a dual problem. This linear programming problem, if your naming is dual, with respect to dual, we will find the primal. Now, so either you have to solve the primal or the dual. If you solve the primal, you can get information about the dual. If you solve the dual, you can get the information about the primal. So only one of the problem will be solved, not both the problem. If it is primal, say which relationship is useful? The complementary slackness principle. I have told with respect to the primal problem, we have a dual problem. There is some relationship. Okay, say something like, say, for example, we have the constants summation over j varies from 1 to n, aij xj less than equal to bi. Okay. With respect to ith constants, we have a variable, a dual variable. Okay. That dual variable we may name is yi. So this constant summation over j varies from 1 to n, aij xj minus bi into yi equal to 0. Either this is fulfilled or yi is 0. This product equal to 0. So this criteria we have to use to find the primal variable, dual variables if it is required. Okay. This is the information about the primal dual. Say either you solve primal or you solve dual. If it is given, solve using the dual simplex method, you apply the dual simplex method, and the primal variables you can find out after calculating. Okay. So this I have already included. So the dual simplex method. Then we have the integer programming. So for the integer programming, say we have two methods, branch and bound method and cutting plane method. Branch and bound and cutting plane method. Cutting plane. Why cutting plane? See, if a linear programming problem is given, so if it is given as integer, you solve it using just linear programming method. Let me say primal simplex method you are applying. If optimal solution is obtained, you check whether the variables are integer or not. If the variables are integer, you stop it. If the variables are non-integer, the optimality condition is fulfilled. Optimality condition is fulfilled means zj minus cj, okay, all are non-negative. So optimal condition is fulfilled. So but the variables are not integer. With respect to non-integer solution, we have to formulate a cutting plane. That cutting plane must be included in that simplex table, and you will go for iteration. Once it is complete, again you check whether the solution is integer or not. If it is integer, you stop. If it is non-integer, again you have to add one more cutting plane. So this method must be continued till you get a optimal integer solution. Okay. This and branch and bound. Branch, I have already told branch how to branch and how to put some bound for the integer variables. So using that procedure also you can find the solution. Okay. So these two, then I have already told the transportation problem is also included. Transportation problem we solve using a standard procedure called transportation algorithm, known as modified distribution method or MODI method. Modified distribution method. Say what we should do. Say for a given transportation problem, we check whether it is balanced or unbalanced. If it is balanced, so with respect to the balanced transportation problem, we find the basic feasible solution using two different methods. One is northwest corner rule, another is known as least cost method. You find the basic feasible solution. There must be m plus n minus 1 number of non-zero solution. Okay. So if you are going to check whether the given solution is optimal or not. So to check the optimality condition, we have to use the dual problem. We have to find the parameters like u1, u2, un and v1, u1, u2, um and v1, v2, vm. Okay. So we have m plus n number of parameters, but we have m plus n minus 1 number of basic feasible solution. So assumed to be non-zero. one less. One of the parameter you set 0, either u1 equal to 0 or v1 equal to 0. We say u1 equal to 0. So setting u1 equal to 0, you can calculate the other parameters. So, and these parameters are dual variables. Since in the transportation problem, all the constants are equally type, these dual parameters are free variables. Dual variables are free. Can be 0, can be positive, can be negative. After finding the solution, you will check whether for each cell, that is ui plus bj is less than equal to cij is fulfilled or not. If it is fulfilled, then it is optimal. If it is not fulfilled, we have to find a loop. Okay, how to find the loop I have already told. So using the same procedure, find the loop and check. So this is the rule for the transportation problem. Then we have the assignment problem. Assignment problem is a special case of transportation problem. So, and this assignment problem, as you know, number of machine and number of jobs are same. It should be a square matrix. So for the square matrix, we allocate. So we can allocate one job to one machine. There are say n number of jobs and n number of machine. Okay, orbital we are not going to allocate. So we are using the Hungarian algorithm. So using the Hungarian algorithm we use. First, what I should do? So we have to, once the assignment matrix is given, say we subtract the minimum element from each row and we see whether there is a 0 in every row or not. Similarly, find the minimum element in each column, then you subtract, then you see that every row and every column must have a 0. Then using that procedure we allocate. Okay, so I have already told how to go for the allocate. Suppose say if the allocation is not complete, we draw minimum number of horizontal and vertical lines to cover all these 0. Okay, say after covering, you see that some uncovered elements are there. So among the uncovered elements, find the minimum, then you subtract, and at the crossing of the horizontal and vertical lines, you add that element, whatever you are subtracting. So then in this manner, you can have additional 0, then you can allocate. So we'll allocate a job or a machinery job, say to a row which has only 1 0, you allocate and cross all the 0 in the same column. And you repeat it. And similarly, once the row is complete, you go for the column. So every column which has 0, then you can allocate. And sometimes, you know, there are 2 zeros. Every row and every column has 2 zeros. That is possible also. So you can select one of them. So if that is the case, then you have the multiple solution, multiple optimal solution for this problem. So these are the rules. So if you have any difficulty, and I have told about the game theory we have, say either the game is stable or unstable. If it is stable, no question of mixed strategy. Directly you will find the saddle point. The saddle point is the value of the game, and we find the optimal strategy. But if the game is unstable, we introduce the probability, and using the linear programming approach, we find the optimal strategy and the expected value of the game. That's all. Okay. So if any doubt, you can ask me, I will explain. Anybody? Hello? Are you available or left?
Yes, sir.
See, yet I have not prepared the question paper, so I will prepare and see. I am sure all will be able to solve nicely. There is no problem, but you have to try yourself. Okay, try yourself. Apply the. They are all simple problems, so not very lengthy. So everybody should be able to solve this problem. Okay, right? And time is 1 hour I am giving. So the 1 hour is enough to solve 5 problems, 5 small problems. Okay. Thank you. So I will not take any more class, and if you have any doubt, you can ask me now. Okay. Hello. How many students are available now? Please tell me.
Sir, around 50, sir.
How many?
Sir, around 50.
Okay. And I have sent the mail to everybody. So one student was asking that he will appear offline. See, 1 or 2 students, it is not fair. Okay. So I will be there in a hall for 2 hours. So, and only one student, something like, but if more students, it's fine. There is no problem. But one student, that is not fine. Okay. Please appear online and there is no harm. Okay. So, okay. Thank you. All the best. Okay. And whatever the assignment you have made, okay, already done. If you have not done, fine. If you have done, please submit. Okay. Send to my email ID. Okay. I have a option to look to your program. Okay. But submit early. But if you submit late, there is no, and not useful. Okay. Thank you. Any doubt? You can ask me if you have doubt. Yes. Hello. You are interested to say something? Hello?
No, sir.
Okay, thank you. So we'll stop here.
Thank you, sir.
Thank you, sir.
Thank you, sir.